Okay, unit review. So you need to simplify, write all your operators. 5 times x to the third, second outside the quantity times x to the fifth. So you got 5 times x, and there's another x, so I add to the first one. So 5 to the first, you take 1 times 2, that's 2. 3 times 2, that's 6, and that's 5. So 6 plus 5 makes 11. Okay, so what do we do with these? Well, since they're both positives, they both stay positive exponents. So they stay exactly where they're at. 5 to the second power. 5 times 5, that's 25. Times x to the 11th. Okay. Number 2, 4 to the second times 4 to the fifth divided by 4 to the fourth. So 4s are wild here. You got a 4 on top, and there's another one which I'm going to add to, then a 4 on the bottom. So you're going to have 2 plus 5, and then a 4 on the bottom. So 2 plus 5 is 7. Then what we do, since these bases match, we subtract that 4 from 7. It's gone. 7 minus 4 is 3. Now that's a stay, because it's positive. So 4 to the third, 4 times 4 times 4, that equals 64. Okay, number 3, x to the third. Remember, in algebra with two fractions multiplied, you're just going to combine that. Okay. So x to the third to the fourth times 2, then y times x to the fifth. So we have a y and a 2, so it's our x and a 2. Denominator, you get a y times an x. So x, okay, 3 times 4, that's 12, and then the 2's to the 1. Okay. Now, the y, you take 1 times 4, that's 4, and then the x you have to the fifth. Now, the y can't be subtracted because it's not on top, but the x sure can be, minus 5. So 12 minus 5 is 7. All these things are staying, okay? They stay. So you take x to the 7th, and then 2 to the first, then on the bottom, y to the fourth. 2 to the first is 2, times x to the 7th over y to the fourth. Okay, number 4, we have the quantity 8 times x to the 6th times y to the negative third to the negative second. Then in the denominator you have x to the negative second times y to the second. Okay. So on top, 8 times x times y. Now on the bottom you have x times y. So once you move across the line, you have to rewrite your bases. You don't add the x's, not when you're dividing them. Okay, so 1 times negative 2 is negative 2 on the 8. 6 times negative 2 is negative 12 on the x. Negative 3 times negative 2 is positive 6 on the y. Now in the denominator we don't have parentheses, so we just put in the negative 3 and the 2. Now, you have x on top and bottom, so we can cancel the negative minus negative 3 from the top. Now remember, that's the same as negative 12 plus 3, okay? On a number line, it'd be negative 12 and then 3 to the right. So negative 11, negative 10, negative 9. This one's a no-brainer. 6 minus 2 is 4. So that's a switch, and that's a stay. So if we got to switch those, the 8 and the x have to switch to the bottom so we can take the negatives off their exponents. So it's 2 and 9. Now on the top, you got y to the fourth. Y to the fourth stays the same. Okay. 8 to the second, 8 times 8, that's 64. Now on bottom you got x to the 9th. Okay, simplify each expression, write the answer in scientific notation. So you got 7 times 10 to the 5th times 2.3 times 10 to the 4th. So we want to reorganize these parentheses. So I have the standard numbers together, 7 times 2.3, and then the 10 to the 5th times 10 to the 4th. So 7 times 2.3 is going to be 16.1. And then 10 to the 5th, 10 to the 4th, we add the 5 and the 4, and that's 10 to the 9th. But now you can't just circle that. You have to make sure your decimal's in the right place. So you start here. Find the first number that's not a 0. It'd be 1. So I have to move the decimal so it's between the 1 and the 6. So I move it. And I moved it once, and since I moved it to the left, we're adding, okay? Okay, so it's 1.61 times 10 to the power of 10. Okay, division's no different. We take the 2.5 divided by the 5, that's 0.5. Now to divide the base 10s, we subtract -3 from the 5. So that's the same as 5 plus 3, which is 8. Now, again, the decimal has to be behind. You can't have just a 0 in front of it, okay? So going this way, you start here. 0 doesn't work. 5 does. So I put a 0 after the 5 and move it so it's between the 5 and the 0. So 5.0, but then we have to adjust our exponent of 8. So I moved it once to the right, so that means I'm going to subtract 1. So that's 10 to the 7th. Okay, then we got the always fun graphs. Y equals 3 times 1/3 to the power of x. So that's an x, the independent variable x is an exponent. So it's an exponential function. Now, we want to do an input-output table starting with 0 in the middle, then 2 to the right, 2 to the left. Now we will remember to times 3 at the end, but first we're going to take 1/3 to the power of these inputs. That's your base. Now I'm going to put a second, a first, a 0, a negative first, a negative second power respectively. Okay, so 1/3 to the second, that's just 1/3 times 1/3. And that's 1 over 9. So if that's 1/9, what the negative power does is it reciprocates what I got with the positive. So 1/9 would go to 9 over 1, which is 9. That's going to be 1/3, and the negative first power just reciprocates the output on the positive first power, so that'd be 3. That's 1. So we have 1/9, 1/3, 1, 3, 9. Now you got to times all of them by 3. 1/9 times 3 is 1/3. 1/3 times third is 1 whole. 1 times 3 is 3. 9, and 9 times 3 is 27. Now we want to start here because that's where the extreme part is. So -2, 27, -2, 27. Okay. Now -1, 9, 0, 3, and then all that happens on the end is you just get closer to the x-axis without crossing it. Okay. So arrow up, then you get closer to the x-axis. Okay, don't cross it. You get extreme that way, but here you don't get extreme. You just get infinitely closer to the x-axis. Okay, y equals 1/5 times 10 to the power of x. Okay, so again, it's another exponent, another one where the independent variable is an exponent, so it doesn't make a line. Now, 2, 1, 0, -1, -2, we're going to have to times by all the outputs by 1/5. So 10, 10, 10, 10, 10. So I take it to the second, first, 0, -1, -2. 10 times, it's not 20. 10 times 10 is 100. Okay. Now that's a big output, but you're going to times it by 1/5, so that will lower it. That's 10. So this is going to be 1 over 100. If that's 10, that's 1/10, and then 1. So you have 100, 10, 1, 1/10, 1 over 100. Now times them all by 1/5. So I take 100 times 1/5, and that's going to be 20. 10 times 1/5 is 2. 1 times 1/5 is 1/5. 1/10 times 1/5 is 1/50th. Oofda. 1/5 times 100th is 1 over 500. Now don't let those freak you out. You're going to start here, okay? So I go 220. 1, 2, that's somewhere in here. Okay, 1/5. And all that happens with these last points is you just get closer and closer into the x-axis. Okay, so that way, and x-axis. So as x goes positive, we go extreme. As x goes negative, we go to the closer to the x-axis. Okay, roots. Cubed root of 125. What times what times what is 125? Well, I don't think it's 1, so I'm going to skip that. 2, not 3, not 4, it's 5. Now remember what a fraction power actually does, okay? It's actually a root with a 3, cubed root, and then I put 27 inside, and it's going to go to the second power. So first I go what times what times what is 27. I just kind of had it up, okay? So I don't think it's 1, 2, nope, nope. It's 5. Now, so this becomes 5, but we got to remember it's still 5 to the second. So we take 5 times 5, which is 25. Okay, next one, we got the compound interest. A customer deposits $600 in a savings account that pays 2.5% interest compounded quarterly. How much will the account be worth in 5 years? That's the formula, so no boxes and tables and crap. So, A, P, R, N, and T. Now, A is where the money ends at. That's what we don't know, okay? P is where the money begins at. So we know the P is $600, money beginning. R is your percent as a decimal. Now, yeah, it's already a decimal, 2.5, but you still have to move it twice to the left. So once, that's 0.25, twice is 0.025, so 0.025. You got to get that 0 in. Then N, well, it's 4 quarterly. And then T is the time, is how many years we have. So the years is 5. So now, A is what we're solving for. The P is 600. 1 is always there. Now the rate, 0.025. Don't just put 2.5. Divided by the N, which we know is 4. And then the exponent is N, which is 4, times T, the years, which is 5. So we know 4 times 5 is 20. So we're going to now simplify the parentheses. I'm not going to take the parentheses to the power just yet. Okay, so I find what 1 plus 0.025 divided by 4 is 1.00625 to the 20th power, and now I solve it. 600 times 1.00625 to the 20th power is $679.62. And that's your answer. Okay, then my last one. The population of a city is 45,000 people. It decreases 2% each year. That means minus 2%. If the trend continues, what will the population be in 15 years? Sorry, I forgot to put people down there. That's my fault. That's your answer. So you got people in years. This isn't compound. Now, could you use the compound formula? Yeah, but you'd have n equals 1, so I mean you could use it. So x is years, y is people. So it's people per year. Now, we don't have the people per year. What we have is a percent, minus 2%. So what this means is it's going to be an exponential function, so I put expo, and we need to know what our factor is. It's a decay factor because it's going down. It's called a growth factor when it goes up. So you take 100% and subtract 2%, and that's 98%, but you need to make it a decimal. So 0.898. Now, table. So years is X, people is Y. So 0, 1, 2. So we started, and we got to find 15 years. So we start at 45,000 people. Now I'm multiplying by the exponent factor of 0.98. So 45,000 times 0.98. 44,100. Now I times again by 0.98. 43,218. Okay, so what do we do on an expo? Well, this is what I'm finding. Remember, that's a times b to the x power equals y. So this is a and this is b. Okay, 45,000 times 0.98. And the 15 replaces the x. X equals 15. So it's the 15th power equals y. So now I plug it in. Okay, now we're talking people, so we don't really want a decimal here. 33,235.36 if you want to put that. You can put 235 or 236. And there we have it. 35 or 36, either one's okay.